So formal charge is basically the charge, assuming that all electrons are shared equally along bonds. This is a pretty big assumption, which has been proven to not be true, because the oxygen in water has a partially negative charge, and the hydrogen has a partially positive charge. Everyone knows that. And their formal charges are both 0. So formal charge already distorts your perception a little bit. If you try and plug in the equations for the Lewis structure of ammonium chloride, you assume that the nitrogen has a partial positive and the hydrogen also have a partial positive charge. But that is not true, because the nitrogen is being reduced by the hydrogen, so it actually has a partial negative charge. The fake structure is the ammonium has a positive charge and the chloride has a negative charge. But in reality, the ammonium chloride exists in equilibrium with a mixture of hydrogen chloride and anhydrous ammonia. Except if it's dissolved, it's not anhydrous, obviously. But the actual electrons are spending more time around the nitrogen and the chlorine. In this example, you might want to consider quantum superposition. If there's 4 hydrogen that are all the same and they're around the nitrogen, they should have the same charge, but some of them are being oxidized by the chlorine and some of them are being oxidized by the nitrogen. But you can't tell the hydrogen apart, so you can never know which are being oxidized by the nitrogen and which are being oxidized by the chlorine. So therefore they're in a quantum superposition of being oxidized by the nitrogen and the chlorine, but since there's more hydrogen attached to the nitrogen, more by the nitrogen. You might be confused because, the sodium borohydride doesn't have the same structure as just an adduct of sodium hydride and borane, but the reason for this is because the structure is correct, but the charges are wrong, because formal charge does not properly display the distribution of electrons.